Welcome everyone. For today's prep, we're going to look at another example for finding particular antiderivatives of functions. And in this example, we're actually given the second derivative of some function f. And, well, we want to recover the original function in this case. So we want to find the particular antiderivative little f of this second derivative f double prime, and the formula for f double prime here is 12x squared plus 6x minus 4. And in order to recover the original function precisely, in this case we're going to need two pieces of extra information about that original function. And why we need two in this case is because, well, we've done the derivative twice. So we have two initial conditions here, and we're going to use those a little later. So the first step in this is, well, we have to kind of undo both of those derivatives that we've done. So our first step is to figure out, well, the general antiderivative. And this is what we do with integrals. So we're going to have to do this twice, though. We're going to have to integrate twice, one for each of the derivatives that we got to get through. All right, so if we do the integral once, that'll give us our first derivative. So let's integrate this second derivative to get what the formula for the first derivative was. All right, so let's throw in our formula here. So 12x squared plus 6x plus minus 4. And there we go. Now we're going to do our antiderivative of this. So antiderivative of the first piece, that 12x squared, if we do our power rule, what are we going to get? Well, we're going to get the 12 is going to stay there. And again, that 12 is just a constant multiple. And let's get the antiderivative of that variable part, the x squared. So that's going to be 1/3 x cubed. Then we do the same thing for the plus 6x. So we want to get the antiderivative of that. The 6 is a constant multiple, so it's just going to kind of stick around in front. And then we find the antiderivative of the x, so power rule there. So in this case, 1/2 x squared. And then when it's a constant all by itself, like this minus 4, we multiply by, in this case, x. So we're going to have a minus 4x. And whenever we find a general antiderivative like we're doing here, we want to throw on a constant at the end. So we'll throw on our plus c at the end here. All right, so doing the integral once, we had our second derivative, and when we did the integral once, kind of canceled off one of the derivatives. So now we have the formula for what f prime is, or was. And let's simplify this down just a little bit. So once we simplify this, we end up with 4x cubed plus 3x squared minus 4x plus c. All right. So it's pretty good. That's just the formula for the derivative, though. So we got to do it again to get little f. All right, so we're going to integrate now our first derivative. And integrating the first derivative, again, you want to think of integrals and derivatives kind of as opposites of each other. So the integration is going to cancel out that derivative, and we're going to be left with just f of x then. So let's go through it. So let's fill in our simplified version of our formula for f prime. So 4x cubed plus 3x squared minus 4x plus c. And we want to do the antiderivative here. So kind of the same process that we did. So what do we have? Well, for 4x cubed, the 4 is a constant multiple, so it's just going to stick around in front. And then we do power rule on that x cubed. So we add 1 to the exponent, take that new exponent, flip it, put it in front. Do same thing for the 3x squared. So the 3 is a constant multiple, so it'll just kind of stick around in front there. And then we do our power rule on the x squared. So our variable is x. We add 1 to the exponent to get 3. Take that new exponent, flip it, put it in front of the x. And we just kind of keep working our way through. So now we get to the minus 4x. And again, minus 4 is a constant. We do our power rule on the x. So we add 1, takes us up to x squared. Take that new exponent, flip it, put it in front of the x. So we get a 1/2 there. And then for the last one, c is a constant. We don't know what it is yet. We're going to be figuring this out for our particular antiderivative. We don't know, though. But it is a constant. So when we integrate a constant that's all by itself, we just multiply by x, just like we did with this minus 4 in the previous step. So we had this minus 4 all by itself, this constant all by itself. And when we found the antiderivative, we just took the constant and multiplied it by x. So we're going to do the same thing here. So we're going to end up with plus c times x. And whenever we find an antiderivative, a general antiderivative like this, we always throw on an extra constant at the end. So we've already, normally we use plus c. We've already used plus c in our work here, so now we just need to come up with some other letter. So, plus d might be a good one. But again, this is just a general constant at the end. All right, so where are we at? Let's simplify this down now. So the 4 and the 1 over 4 are going to cancel. The 3 and the 1 over 3 are going to cancel. And maybe, once you get the hang of these, maybe you're just doing those steps in your head right away. And then the 4 and the 1/2, we'll get a little bit of canceling there as well. So when we simplify this, we're going to end up with x to the 4th plus x cubed minus 2x squared plus cx plus d. All right, so we're pretty good at this point. We have most of our function for little f of x. The only thing left to do now to find the particular antiderivative is find these missing constants. So that's going to be our next step. And we're going to figure out plus c, and in this case also plus d. And this is where those initial conditions are going to come in. So if we go back up, these are our two initial conditions. F of 0 is equal to 4 and f of 1 equal to 1. And again, why we need two of these for this problem is because we were starting with our second derivative. So each of those derivatives, we kind of lost a little bit of information about our function. And when we went and kind of did the integration, we ended up with two constants. So it's not a coincidence that we end up with two general constants here, and we have two initial conditions. That's what we need to find both c and d. All right, so let's start with f of 0 equal to 4. So we have this condition. So what this says is when we plug x equals 0 into our function, what we have for our function so far, we should get out 4. So let's see the equation. So when I plug 0 into our formula so far, I'm going to get 0 raised to the power 4 plus 0 cubed minus 2 times 0 squared plus c times 0 plus d. And whatever all of this ends up simplifying to, it should be equal to 4. So again, the number that I'm plugging in is x equals 0. So wherever I saw an x, I plug 0 in. And the number that I'm getting out is 4. And that's what I'm setting the whole thing equal to here. So if I simplify this down, this is going to give me an equation that I can solve or work with. So I'm going to solve this equation here. And if we simplify it down, well, 0, 0, 0, 0, so I just get d is equal to 4. So this one's actually kind of easy to solve. All right, so that's nice. I know one of my constants now. Well, then I can use my other initial condition. And I forget, what was that? F of 1 equal to 1. So we're going to, let's write that down. And we're just going to plug in x equals 1 into the formula that we have so far for our function. So f of 1 is going to be 1 to the power 4 plus 1 cubed minus 2 times 1 squared plus c times 1 plus... Now, when I'm plugging in x equals 1 here, I could write d, but I actually, at this point, I already know what d is. So I could use that. And again, when we do this, what we're doing is we're plugging in x equals 1 wherever I see an x in what we have for our formula for our antiderivative so far. And then the one that I'm setting this equal to is whatever my initial condition is for that x value. And this gives us another equation that we can solve. So we can end up with two equations here that we can solve. And if we look at this equation now, if we kind of simplify it down, we end up with 1 plus 1 minus 2 plus c plus d is equal to 1. So the 1 plus 1 minus 2, that's just going to simplify to 0. So this equation actually simplifies to just c plus d is equal to 1. And this is where I can go back to my previous results and just kind of use that. Sometimes we might have to do more work with this previous result. So maybe we have to solve this equation for c, or maybe we have to solve this equation for d, and then we can plug that into the second equation and then keep solving. But in this case, I know what d is, so I can plug it right in. And that gives me c plus 4 is equal to 1. And then if I solve that, I get c is equal to negative 3 by subtracting 4 from both sides. All right, so now I know what c and d are. So now my last step is just put it all together. So now we write down our particular antiderivative. And we'll have it. So we know that f of x, what was it? It was all of this. And then we just plug in our values for c and d. So it's x to the 4th plus x cubed minus 2x squared. And instead of plus cx, I know my c value was negative 3. So let's actually fill that in now. So we'll have negative 3x. And then instead of plus d at the very end, I know my d value is 4. So we find our particular antiderivative here. All right, so we'll probably try a few more of these in class. So we'll see you then. Bye-bye.